I wanted to ask a few questions. One, do we know how many years did NASA need to research and develop spacesuits that Neil Armstrong and Buzz Aldrin used?
Oh, that's a good question. I honestly don't know, but I'll be happy to make sure I get that back to you. So the question is, how long did it take to develop the original moonwalking spacesuits? We'll look that up.
Thank you.
Wow, really? There you go, guys. Like, duck and cover, make America great a team. That right there is an evangelical Christian like Mike Pence who believes the earth is flat, who believes we can't leave the firmament, who is working with the Trump agenda to dismantle all of our government agencies from the inside. So, this is Trump dismantling NASA. It is a long-term plan, and the first thing you do is you prove that they can't do that one thing they said they do. Give them all the money in the world. They can't do it. She asked that simple question. He can't even answer it. I've got an answer for it. Here, let me give you a couple NASA curators saying the exact same thing when they're confronted on what about all the radiation the spacesuits will have to encounter when traveling in, deep space.
I was wondering, maybe to both of you, what are some of the challenges that you see coming up in spacesuit design, especially as we think about going to Mars and maybe beyond to some of the moons, like increasingly hostile environments in space, and dealing with problems of ionizing radiation to astronauts over long periods of time. So just
This one is a human cell.
See that time lapse?
This is a human nucleus, so it's 10 microns approximately. And these two lines that you see here are two iron ions that you don't find in space. I'm sorry, that you find in space but not on Earth, except in Darmstadt at GSI, where we have it, going through the cells and making damage to the DNA.
See the time lapse? Yeah, that's not a long period of time. Those aren't long durations.
and what your thoughts are in that direction.
It's a good preview question for, I think, what we're going to hear about, but go ahead.
NASA curators. History, suits.
Well, as I had said, the first thing you do is you have to look at the mission. The jump from Gemini to Apollo is very important because the astronauts had to walk.
Someone wasn't expecting this question.
ISS, the astronauts don't have to walk, so the lower half of the suits are not very mobile. So everything goes to mission. As far as radiation is concerned, that is a concern, and I think David is probably better trained to answer that.
Low weight suits, very low mass, very mobile. That's sort of the future. We think of design and development. Radiation is maybe the number one showstopper to keep our astronauts healthy and well. Don't think it makes sense to incorporate that into the suit design. It makes sense to incorporate that into your shelters and things like that, because you need a very high, dense, high massive protection of the radiation. So I kind of decouple the two, thinking about the suit and life support system design, and then your habitat and rover design, which are better equipped to do the radiation protection.
What do they know, right? They're just NASA curators, so it's not like, we can ask an astronaut. Oh, wait.
I'm Mike Massimino, and this is how health is different in space. One of our biggest concerns for astronaut health in space is radiation exposure.
So who else could we ask an opinion? I understand that TED Talks, anyone can do them. But what if it was the tops in the fields giving the TED Talk? I mean, it's kind of silly to look down at, the leaders of Microsoft for sending out Bill Gates to give a TED Talk. You can't really discredit the TED Talk when it's about Windows and Bill Gates gives it.
I'm here today. I want to talk about space exploration challenges that are still in front of us as we go forward. We've solved a lot of them in the past, but there's a couple of key ones that we still haven't solved, and I would say we need your help to do that. So that's what I'm here today to talk about. We need to solve that problem. We need to solve how we protect ourselves if we're going to do these missions to Mars and other places in deep space. And we do not have the answer for this yet. This is one of the things we just don't.
You will not solve the problem using passive shielding. You can think of active shielding. You can think of electrostatic shielding. I mean, some kind of electrostatic spheres that protect the astronauts.
Who else
Or
would
even
say
better,
something like
think
that?
to this thing. This is
Who would think of that? I know who else says that. NASA. NASA says that. Their own channel. This is how they upload all of their videos onto their .gov site. So if you go to their .gov site and you see a video on all of the descriptive information they're giving, it's just because they uploaded it here on their NASA Goddard Heliophysics section. And you'll find they confirm what Marco Durante told them when they asked him to tell them what would happen 4 years ago. They started saying this last year, all right, this is exactly what he said and we fully agree. And they started just over the last couple of months with here.
Unfortunately, the moon's patches of magnetic field are not robust enough to completely protect human explorers from the sun's radiation.
As Marco Durante said,
Magnetic fields could lay the groundwork for future innovations.
Well, what if we got a strong enough magnetic field that perhaps we could produce artificially? That's a question that I think remains to be answered, but the crustal magnetic fields on the moon and lunar swirls kind of provide a hint in that direction that we might be able to learn something about.
But who does that guy think he is, right? Oh, that's right. Prestigious universities are the ones saying that we need active shielding surrounding our crafts, and obviously we need our suits to be within that. Something like GSI just said, the magnetosphere. Well, who else would agree that the Apollo craft needs to have like a magnetosphere around it or electromagnetic shielding? Because we don't want to call it active shielding or anything like that. That's what Marco Durante said. That's Gene Roddenberry. That's Star Trek. I mean, we just need some warp speed next, like an ion drive, nuclear propulsion, like Gene Roddenberry said. Anyways, I digress. NASA might say something like that. Let's check out what they say.
The spacecraft.
Passive shielding.
Other possible techniques in development
Marco say?
include Vesper and mass, and electrically charged surfaces that deflect particles.
Why would you need electrically charged surfaces that deflect particles? Like Marco Durante said, like an atmosphere that is surrounded by a magnetosphere?
I think I was supposed to give ideas here. It looks like, radiation is a problem. This is clear. Shielding, passive shielding can be a solution on the planet, but not really on transit. Maybe the best solution, the best idea is to use a magnetic shield, is to build magnetic fields for the spacecrafts that can do what is done on Earth. So it's not really a new idea. It's the same idea that God had a few billions of years ago when he said, okay, I want to make life, but I created radiation already. What can I do now? Okay, maybe I can make a magnetic field,
And so this is where we leave off. Since obviously we can't go to the moon, we can't design suits or crafts with magnetospheres, anything to deflect the particles that will cause cancer within the time lapse shown. We're going to do catwalks. We're going to throw hair gel. We're going to strike a pose. Obviously, that's the new EVA suit. It's going to be easier for them to work, being able to pivot their upper bodies to be able to reach and do things as needed in low Earth orbit. The other suit, it's specifically look at what the Soyuz uses to launch us up into the thermosphere. It's the same suit. So they redesigned or recolored or rebadged the Soyuz's everything again. So this is just the newest attempt at an EVA suit and our attempt at making a regurgitated suit like Roscosmos has.
So, just so everybody knows, Christine's spacesuit is under pressure right now. And that usually makes it very difficult to mobilize. And yet, what is she doing? She's moving around. If we remember the Apollo generation, you remember Neil Armstrong and Buzz Aldrin, they bunny hopped on the surface of the moon. Well, now we're actually going to be able to walk on the surface of the moon, which is very different than our suits of the past. So if you would, Amy, tell us a little bit about the thermal environment on the moon and how this suit is going to be helpful in that environment.
Yeah, we normally try to plan for a thermal environment that ranges from 250 degrees Fahrenheit to minus 250 degrees Fahrenheit, with some potentially colder spots in the south pole of the moon. And so we are looking at the materials and the protection for this suit to keep our astronauts comfortable while they perform their job.
So you're saying that Christine in this suit would be able to be at plus 250 degrees Fahrenheit or at minus 250 degrees Fahrenheit in the exact same suit?
Yes, because the suit she's wearing is pressurized to have an atmosphere for her. However, that's because she's in the thermosphere, safely within Earth's atmosphere, and, because it's well under the thermosphere, it's well underneath the exosphere, where we are at with our EVAs is at 230 miles up. When you leave the atmosphere, you're at 6,200 miles up. So, when you start to go into the magnetosphere and then leave Earth's magnetic bands and you're not protected like Marco Durante showed, you would be exposed if you weren't. Well, then this suit right here would need more than just atmospheric pressure within the suit. That's why they're going to say,
yes, we can. And so for the moon, we're using materials that allow us to do that. And when we go to Mars, we're going to need a new insulation because that has an atmosphere in Mars, and our insulation depends on the vacuum of space right now.
Awesome.
that's where you guys are at. There's your suit designs, there's your nonsense. It doesn't matter. If you don't have a magnetosphere, the suits don't mean anything. So they're staying within low Earth orbit, and that's it. So until you have a magnetosphere on your craft, you're not leaving low Earth orbit. And the suits don't have magnetospheres. They have coolant that's flowing through them, and that's the same as Apollo. And that's the same as every suit that we're using at 230 miles up for EVA missions. So this is just another EVA suit, and a suit to get us from point A to point B, and point B being 230 miles up. Duck and cover, guys. Make America great again.